This is going to be example 3.3 from the OPENSTAX AP Physics textbook. All right, here we go. Now, if you're following along in the textbook, you'll notice that there's a lot more words in the textbook than just this picture. But for space of recording's sake and for clarity, I figured it would be easier to just put the picture. But what the instructions say is we have these two vectors. We have this vector A, this red one, and then we have this vector B, this blue one, and we want to add them with analytical methods. In other words, we want to add them using math. In our last couple of examples, we were adding vectors using not really, it is math, but more just graphical methods, right? So, without further ado, here we go. So, in order to add vectors analytically or with trigonometry, with mathematics, you have to split them into their components. So you have to split the A vector into its X part and its Y part. And to do that, we use simple trig ratios. It's really, really that simple. So in order to find the X part of A, we'll label this as A sub X, because that'll work for us. What you do is you take A, the length, which is the length of A, which is given to us as 53 meters, and you multiply that times the cosine of the angle at A. So theta sub A is what we're going to use for that. All right, so that's what we're going to do. I'm not going to write out every single one of these formulas, but we'll for the sake of space, but we'll see. We'll see what we can fit. All right, so A is 53, so we're going to put a 53 in here, and then cosine of 20 degrees. Now make sure your calculator is in degree mode when you're doing these, not in radians, because you'll get the wrong answer is if it's in radian mode. And so make sure it's in degree mode. So then all you have to do to find the X part of the A vector is just stick that in the calculator. We stick that in the calculator. See, I have it written down here. It's already done. So it comes out to be 49 and 8/10. So 49 and 8/10 of a meter. You can verify on your calculator. Just stick it in there. 53 times cosine of 20. Bang, bang, bang. So I'm going to put this over here for safekeeping. A sub X equals 49 and 8/10 of a meter. And I'm going to erase all this stuff. And let's do the next part. So to find the Y part of the A vector, we do the same thing, but this time we're looking at the opposite over the hypotenuse. So this is the opposite right here, opposite of the angle, and then the hypotenuse is right here as always. So instead of using cosine, we're going to use sine. So the A sub Y equals, same thing. It's going to be A, which was 53, times the sine. I always write my sine and cosine. Well, I don't always. Obviously, I didn't just now. I like to write my sine and cosine in cursive, so that way it's easy to know that it's the same thing. Of course, when I do it on the tablet, it kind of comes out to be a mess. Sorry, but that says sine. Well, it actually says sin, but that's abbreviation for sine because there's no sin in math. Okay, 53 times the sine of the angle. The angle for this one is 20. So there it is. It's that simple. So you stick that deal in the calculator. Let's see. When you calculate that out, we end up with, I'm going to put it over here so I don't have to rewrite it twice. We end up with 15 and a fourth. So 15 and a fourth meters. That is the Y component of the A vector. So we're going to call that A sub Y. All right, let's erase this and let's move on to the blue vector. And so I'll change my color to blue. Sounds good to you? Yes, it does. I even made it rhyme. Look at me. Mr. Smee. Okay, that's pathetic, but you know, that's okay. All right, so we do that. We follow the same process. So for A sub X, it is, excuse me, not A sub X. We're not on A anymore. B sub X is b, which is 34, times the cosine, because for the x part, we're talking about the adjacent over the hypotenuse. Adjacent over the hypotenuse, because this will be the x over the radius there. Okay? So 34 times the cosine of, this time it's 63 degrees. 63 degrees, sorry. And for the b sub y, it's the same idea, but this time we have the opposite over the hypotenuse. So we're going to use the sine. So it's 34 times the sine, that's closer, that's less ugly, of, what is it, 63. So you stick both of those in the calculator, and then once we get them, we end up with b sub x equals, oh, I read the wrong space on my thing. B sub x is 15 and 4/10 of a meter. If you're actually following along at home, you probably have already screamed at me. This one, a sub y, wasn't that. Let's see, a sub y was actually 18 and a tenth. Oh, I'm messing up everywhere because it should be red. So let's get my red back. Whoa, yes, that one sounds great. And what did I say it was? It was 18 and 1/10 of a meter. All right, so for my b sub y, when you plug that in the calculator, you end up with 30 and 3/10. 30 and 3/10 of a meter, and that is the y part of the b vector. Okay, so let me erase this stuff. So now when we add them, you just add it component-wise. So you add the x parts together, so 49 and 8/10 plus 15 and 4/10, and you end up with we're gonna say r sub x for this r vector. When you add those together, that's let's write that all the way out. I'll go ahead and change colors, leave that. We'll make r be yellow because you're not gonna be able to see black. So that is 49 and 8/10 plus 15 and 4/10. So that's our x parts, this one and this one. When you add those together, you end up with 65 and 2/10 of a meter. Okay, so for the y component of our r vector, r sub y, you do the same thing, but you add the y part. So it's 18 and 1/10 plus 30 and 3/10. When you add those together, let's see, we end up with 48 and 4/10. So that is the x and y part. So what we just found is we found that this length from the origin, let me switch it to black. Okay, from the origin to right in line here, that one is my x part. So that one was a 65 and 2/10, right? And then the y part of this vector, so this distance right here, mark that as a right angle. This one is 48 and 4/10. All right, so that's what we just figured out, which is great and useful and handy. However, the problem is that that's just those numbers is not in proper vector form. So I'm going to stick these over here, and then I'll show you how to do those. So let's grab my eraser and erase these now that we're done using them. Okay, and so I'm going to put let's grab this yellow again. R sub x equals 40, no. Sometimes working live-ish on camera is fun, and sometimes it's not. R sub x equals 65 and 2/10 of a meter. We can do it. You can do it too. And R sub y equals 48 and 4/10 of a meter. Okay, so let's erase all of this. So I drew on there what we have. So we have this side of a right triangle, and we have this side of a right triangle. If you know two sides of a right triangle, you can find the third using your favorite thing. You can use Pythagorean theorem, right? So a squared plus b squared equals c squared. So that would be the square root of this squared plus this squared, right? So r, the distance of r, the magnitude of r equals the square root of 65 and 2/10 squared plus, extend that on out there, 48 and 4/10 squared. Okay, so when we take and we stick this in our calculator and calculate all this out, when you do all the math, you end up with r, that's the magnitude of r, is 81 and 2/10 of a meter. So all we need now is the direction of this r vector. Now, it's actually already given to us. It's given to us as 36 and 6/10, but let's verify that using our trigonometry. So if we look at this angle that they're labeling as theta, this one right here, which corresponds to this guy right here, that angle, if we look at this r sub y and this r sub x right here, then they are the opposite and the adjacent to it. So if we're talking about trig ratios, we're talking about tangent. Now, if we have the sides and we're looking for the angle, we use the inverse function. So in order to find theta, we take the inverse tangent. Remember, we write that as tan -1, inverse tangent of the opposite, which would be 48 and 4/10 over the adjacent, which would be 65 and 2/10, right? So then when you plug that in your calculator, you should be able to verify that theta, in fact, does equal 36 and 6/10 of a degree. So if you wanted to write this answer in full long form, which is what you want to do, you would say that they traveled 81 and 2/10 of a meter, 36 and 6/10 of a degree, and then you have to say, you can't just say that in degrees. You kind of can if it's north of east, which this one is. You kind of can because that's like the default mode. That's how that works, but it's best to write it out. Now, I like to write simple shorthand. I just do north of east. I don't know that it's technical, but it works for me. You could actually write it out north of east if you wanted to and made yourself feel better. That would be great. But that's it, and that's all there is to adding vectors with trigonometry. It seems like it's a lot of work, especially doing it this way on this video, but really, if you think about it, we just did the same thing a couple times and another thing, the same thing a couple times, and then we just did some Pythagorean theorem, which you've been doing for ages, and inverse tangent, and that's really all we did. We barely even used any formulas. I mean, we did kind of, but there's not a lot there. So if you kind of remember the basics of trig, you can handle this without any problems. We'll see you on the flip side.